some individuals can't see the slides. Can everyone see the slides?
Yeah, I can. Thanks, God, Cameron.
Okay. Thanks, man. All right. If you guys can't see the slides, please just comment in the chat, and then I'll be able to address that as and when need be. All right, here. Now, as I asked earlier, what do you guys understand nutrition to be? Like, look, what is nutrition? Like, if someone came up to you, or as a trainer, someone comes up to you and they say, "What is nutrition?" What would your 1 or 2 line response be?
Hey everyone.
I think
Right. Let's let Iman just hang on a moment. Let's let Melo go quickly. Morning, Melo.
Morning, good morning, Cameron. My name is Pimelo, by the way, for everyone.
Melo. Okay.
Greetings, everyone. I think for me, I'd say nutrition is a basic necessity for every human being. Not necessarily just within the health and fitness, environment. Essentially, I think it's a way of keeping yourself in a state of health, health and wellness, and also a strategy on how if you want to gain, if you want to bulk up while remaining healthy, or if you want to lose weight and remain. I think it's a basic necessity in terms of how you want to
Mm.
your fitness. Yeah.
Okay. Okay. No, good. Emmanuel?
oh yes. Good morning, everyone. Let me see if I can quickly put on my camera here. I don't know if you all can see me.
Yes, good
Good
morning,
morning,
Emmanuel.
everyone. Yeah. So I think for me, it transcends more than just what we eat and what we drink. It boils down to eventually how what we put into our body helps us to attain a certain health and fitness level, if you like. And essentially, it forms a greater part of our overall health. We tend to say it makes up the 80%, and physical activities just makes up the 20% out of the 100. So it's quite large. It's quite a huge
Mm.
aspect in terms of health and fitness for me.
Okay. That's very good. Tisetso also says here in the comment section, it is what you eat and drink, especially for pre-workout and recovery. Now, all of you guys are in your own shape, size, or form very correct. And that's also one thing that I encourage you all to do is how can you individualize what you are doing, right? It's great in practice. We can all read a textbook. We can all Google. We can all use ChatGPT and all of these things to sound as smart as we want to. But what does it mean to us? Because when you understand what it means to you, that is how you are going to deliver it to your clients. That's how you are going to deliver it on social media. That's how you are going to, embody that, right? But what often people forget about nutrition is it's often a topic, a niche topic that comes up with health and wellness and performance. And, as your colleague Setso said very rightly, it's what you eat and drink, especially pre-workouts and recovery. And we somewhat take nutrition and we put it in a box. We just put it underneath the health box, and we just leave it there. But nutrition transcends everything. For example, right? If you picture a car, right? Would a car run better on better quality fuel or on lower quality fuel? Arguably on the better quality fuel, right? Now, granted, the one thing that we need to look at is not everyone has access to the same quality, right? However, if we are able to understand the principles of nutrition and deliver that, it doesn't matter where you fall along the socio-economic curve, people will be able to apply that knowledge to their current situation. Is that a fair way to look at that? Because I think that's the one thing that people forget is that if we go and watch a TikTok influencer talking about nutrition, but they're telling everyone that they must have salmon and they must have all these weird and wonderful things, and that they're having, this wonderful protein, this new isolate protein, and all of a sudden you're like, okay, let me go see how much that costs, and all of a sudden it's like $1,000 or something stupid like that. How is that transferable to the greater population of the world? It's not really. Right, and especially when you start your training journey, you often are going to find yourself working with more individuals who are just getting started or who have very little knowledge while you build up your own repertoire in the field, and then you can slowly start to, I don't want to say nitpick, but you can slowly start to work on a different side of it. Maybe you go more towards a Hyrox, maybe you go more towards a bodybuilding or health in general health, etc., recovery, rehabilitation, you name it, right? But nutrition is what drives everything. If you are not fueling the body adequately for whatever you are doing, it can be working behind the desk, it can be for your day-to-day job, it can be studying, it can be exercise, it can be recovery, you know it. If you do not fuel yourself adequately, it doesn't matter what you try to do, where's your body getting that energy from? Where are you going to, when you need that extra little push, where are you going to get that from? Now, what people also forget about the body, which we'll get to, is your body is effectively an electrical system. And the currency of that electrical system is your vitamins and your minerals, right? When you guys go and individuals check for your heart rate variability, when they're checking how healthy your heart is or how healthy your brain is, they are measuring voltage or amperage. They are looking at the electrical conduction of your heart and of your brain, for argument's sake. And when you look at that, that shows that there's an electrical potential throughout the body. Now, if you think of your heart and your brain as the two probably most vital organs, because if your heart doesn't pump blood to your body, how are you going to be able to function? And B, if your brain isn't functioning correctly, how can your brain tell your heart what to do, etc.? Now, when you look at that, the efficiency of those systems is entrenched in nutrition. So from there, a lot of the time when we look, especially in sub-Saharan Africa, a lot of our health problems, if we look at the overall healthcare sector, are caused from malnutrition, right? If you look at neural tube defects or anything like that, right, a lot of it is stemmed in malnutrition. And all that it is just changing how we view fuel so that we can optimize it more to our day-to-day individual. Sounds good. Right. Now, today what we're going to be looking at, guys, is we're just going to break it down. How I break it down is we're going to be doing macro and micronutrients, energy balance, food groups, various different approaches at labels, and then dietary supplements, right? Why do we go in this order? Because we first need to know what exactly are macro and micronutrients. So understanding the overall food groups a lot better. Then what is the energy of it, the actual, quantifiable variable of the food? Then what are the different food groups that we are going to look at? Then you have labeling, so that when you yourself are looking at different foods or explaining to clients, why did you choose this food over this food? They can also start to gauge what you are doing with regards to the nutrition, but also, looking at labels. It's great. We walk into the shops and we can see all these different things, but how can we make an actionable choice effectively? And that's just by, for example, the easiest one would just be looking at the label, not just the price. It would be great if we could just look at the price, and then hopefully the cheapest one would always be the better one. But, if we can add that extra little bit, then we can also help cater for that. And then dietary supplements, because this is so big. When people start training, when people start working out in the gym, the first thing people normally say is, what supplements do I need? Do I need a protein? Do I need a pre-workout? Do I need this? Do I need that? Right? Why do we do that? Because it also is cool. It gives you something new, something. It's like, I'm sure we've all have gotten a new shaker before, right? And you go into Dis-Chem or you go into Clicks or something like that, and you get this new shaker, and you almost treat it like gold for the first week. Like you treat it like gold, like you put it down next to the squat rack, or you put it down next to the bench press or whatever, and you almost just like you almost clean it every day, and within a month you're just tossing it into your gym bag. You're just like, no, I just launch it where the case may be. But we'll get to dietary supplements as well. Now, when we look at macronutrients, there are three, right? Proteins, fats, carbs. When we look at micronutrients, there's vitamins and minerals. Straightforward. 5 in total, 3 macro, 2 micro. Now, a lot of the times, you'll hear people talk about if it fits your macros, right? You'll hear individuals say, you can just swap that out for that. It's not necessarily as simple as that. It's not necessarily as straightforward as that. But what we are going to be able to understand here is why are proteins so important? Why are fats so important, carbs, etc.? But how do they function, right? Because now you can start to think to yourself and you can start to build your own knowledge bank of, for example, okay, now I understand why protein is so important, or maybe why I should maybe have fats early in the day, or why are carbohydrates commonly associated with pre-workout, or whatever the case may be. So what we want to get out of this is for you guys to be as empowered as possible and as knowledgeable as possible to at least start that initial process. Would everyone be in agreement with regards to that? Cool. Now, if we look at protein, so some of the essential protein functions are the following. They are the building blocks to new cells and repair old ones. They are enzymes which catalyze body processes, aiding in the digestion and absorption of food. They are a source of fuel when muscle glycogen is low. And what this means is, for example, you have the 3 energy systems. You have your phosphocreatine and ATP, you have glucose, and then you have your fatty acid glycolysis effectively, right? Or fatty acid oxidation. Now, what that's saying is that after you use all the sugar, the initial glycogen glucose that you have, right? Because remember, your body converts glycogen to glucose, right? So when you eat, you get glucose in your bloodstream. Whatever isn't used, 9 times out of 10 is stored as glycogen. Once the glycogen cells are filled up, then whatever is left is stored as fat. And that's why individuals put on weight a lot of the time, is because they're eating so many carbs that they are just going too much. So then once those glycogen stores are full, they just convert into fat. But what this is saying here is when it says as a source of fuel when muscle glycogen is low, once those glycogen stores are fully used, it is easier for the body to convert protein or muscle into energy than it is for fats. Makes sense to everyone? Now, they also provide a structure for muscles, tendons, ligaments, organs, bones, hairs, skin, and all other tissues. Yes, Emmanuel, do you have a question?
Oh no, sorry, I was just saying yes, it is clear.
Okay. No worries. Sorry, sometimes I ask rhetorical questions like that. Sorry about that. But they also act as hormones which regulate body processes. There are antibodies or immunological substances, and there are also contractile proteins which make up the skeletal muscles, and then there are also blood proteins which make up hemoglobin and albumin. Now, bear in mind when we look at hemoglobin, that's the oxygen carrying capacity of blood. So then you get oxyhemoglobin for oxygenated blood and carbaminohemoglobin for deoxygenated blood. And all that is that hemoglobin group will attract an oxygen group or carbon dioxide group. And what that does is that's why we get that different color of oxygenated to deoxygenated blood, right? And how we are able to do that. When we think of contractile proteins, you guys, I'm not sure if you guys have heard of the sliding filament theory. And the sliding filament theory is how you have your 2 microfilaments called actin and myosin, and they work together to enable you to contract your muscles. And they almost glide along the muscle fiber, right? And they pull and push, and they're activated by calcium. Now, if we look at the next one, we also use protein as an energy source. Is wasteful. Protein is used as an energy source if inadequate amounts of carbohydrates are consumed. So at-risk individuals for this would all be endurance athletes, individuals who are physically active for most of the day, individuals on very restricted calorie diets, and bodybuilders who consume protein at the expense of carbohydrates under the mistaken belief that the extra protein will result in muscle gain. So, like with anything, you may have heard the saying, too much of a good thing can be a bad thing, right? Now, this isn't saying that protein is bad, but we do need to understand that too much can also cause various digestive issues, you name it, right? But the main point is that protein is a great source of fuel, not just for your normal functionality, but for the overall approach to fueling your body. Okay. Now, when we look at protein, we also need to understand that there is the need for dietary proteins or amino acids in healthy adults is due to the constant turnover of cells, the constant breakdown or regeneration of cells in the body, as well as amino acids are recycled. However, this is not completely efficient. Therefore, dietary amino acid intake is required to replace the losses. And what we're looking here is your amino acids, right? Yes, Miller.
Yeah, there's something that kind of stuck with me. You spoke about
Yeah.
much protein. You know that again. Can you please go back a slide?
Yeah. One more.
When you said it's also fuel when muscle glycogen is low.
Yes.
With regards to protein being too much. So essentially, I wanted to ask: are you saying that too much protein in itself can cause weight gain?
No.
In
One.
excess?
No. So, like with everything, like too much protein, which we'll get to in the next couple of slides, can also cause various different scenarios in terms of it can put a lot of strain on your digestion. But what I'm saying here is a source of fuel. So you have your different energy mechanisms. So your body first gets energy from your phosphocreatine system, ATP, but that's very short. That's only a couple of seconds. Then you get your glucose, right? And that's where majority of us get energy from, is from our glucose within our blood, but then also glycogen. Okay? Glycogen is the stored form of glucose. Now, what happens when you eat carbs, right, is you will initially get carbs in your blood, but your body will store it as glycogen, right? So it will store. Now, let's say you only have this much storage. Once this gets filled up, you have all that glucose that is left, for argument's sake. That if it has nowhere to be used, if you're not exercising or if you're not doing anything active for you to use it in the blood, what it then does is it gets stored as fat, right? What I'm saying here is, let's say you start to exercise, so you use all that glucose which is in the blood, and then it takes its reserve and it converts it from glycogen to glucose, right? And you use all of that. So now you've used all the glucose in your body. What then happens is that it is more thermogenically and more easier for the body to then, if you look at your muscle, your protein, to break down muscle before it breaks down fat. So if you look at the weighting of it, you have carbohydrates, which are 4 calories per gram. You have protein, which are 4 calories per gram. And then you have fats, which are 9 calories per gram. So if you look at that from just a energy point of view, it's easier to use the 4 than it is the 9. Right? Because it's going to take so much more energy to break down the 9 where you could just break down the 4. So that's why protein then becomes a source of fuel when the muscle glycogen is low. So your body's first going to try and target muscle before it starts targeting fat. Yeah. That's why if we all watch the Olympics, right? If you look at the long distance runners, You've seen how nimble and slim they are, right? Because if you think when you're running long distances, once you finish using up that glucose, your body's going to try and target the muscle, and then it's going to target the fat. They burn through so much energy that the body will use all the muscle that is required, all the protein, and then we'll move on to all the fat. So it's going through all the processes. But that is what I meant by a source of fuel when muscle glycogen is low. Am I explaining it in a way that you're able to understand, or not really?
To a certain extent.
Okay, what would you like to be better explained?
No, I did understand you. Obviously, I initially thought that fat was going to be the first target, that was going to be worked on as opposed to muscle. For instance,
Mm.
when yes, so I think that aided in understanding that now first target would be muscle fat,
Yeah.
and yeah, just like the whole process, like of how I think I'm someone that's very invested in trying to know really trying to know the process of how it
Mm.
actually unfolds as far as like the glucose in the blood and how it contributes to the entirety of like of
Mm.
energy.
No. I mean, look, guys, this is what we want to do. We want to try and challenge each other, and we want to try and understand the system, right? And that's why losing weight can become so difficult, is because you're dealing with all of this. And that's why most of the time when someone creates a nutrition plan for someone or an eating plan or whatnot, we try and keep the protein high. If we continue to feed the body protein, we can go through that muscle regenesis process, etc., and we can keep fueling the body to keep packing on that muscle. But if you don't have that adequate amount of amino acids to regenerate that muscle, then you are going to lose weight, but you're going to lose weight and you're going to start to look a little bit skinny, so to speak, right? But and if you ask most people, what do you want to, if you want to look like, and you give them different photos, they'll 9 times out of 10 choose the one person that is maybe not as skinny, but they look more aesthetic. Now, people want to look aesthetic, not skinny, but they think that the way to get there is to get skinny. It's not. You get there by putting on muscle mass that has an element of shape to it, right? Getting skinny is a completely different process entirely. Most individuals who are skinny have very little muscle mass, right? And it's that muscle mass that we are after. And the only way you can get more muscle mass is to feed the body the nutrients that is going to develop that muscle mass. And in this case, that is amino acids. The only way that you're going to get more amino acids in is through sources of protein, be that natural or synthetic, for example, supplements, protein powders, or food. But you also have to train the muscle to a point where you break down the muscle that it needs to come together to absorb those nutrients to grow back bigger and stronger. And that's the whole process of training as well, is you breaking down, breaking down, regenerating. And then that process over a long period of time generates hypertrophy or muscular growth. But when we're looking at from a energy point of view, the body's still going to take that stuff. So that's why we train, within certain degrees of failure. And that's why we make sure that nutrition is on point, because it's not just one or the other. It's not just, well, I want to have my cake and I want to eat it. We need to understand that both play a role, and how can we enable the body to function in that in as best as possible. And that's why working with individuals cannot be a cookie cutter approach. You cannot just take, if I made a meal plan and I gave it to all of you, granted, maybe on a thermodynamic point of view, everyone may lose weight, but one individual may lose weight and still look great. Another individual may lose weight, but if a strong breeze came up, they would blow over. Whereas there may also be an individual there that does not lose weight, but rather puts on weight. So it also is showing you that you cannot individualize performance. Sorry, not that you cannot. You have to individualize performance. Sorry, You cannot generalize performance. You cannot just be like, well, if it worked for this person, it must work for the next, right? You can't. Don't be naive to that point where you just think that if it worked for one, it will work for another, right? Because of these intricacies. Any further questions on this? Does anyone else have any questions? As we go on, and when we touch the carbohydrate section, you'll be able to tie it together better because you'll be able to see how the carbs are used and being able to get there. All right, cool. So one must consider two key factors when estimating an individual's protein intake: is their calorie intake and the biological value of protein. This is very important as well. Now, when you have a negative calorie balance, protein can be used as an energy source. Therefore, protein cannot be used for the purpose to fill amino acid pool. Therefore, if caloric intake decreases, protein intake should increase. Remember what I said, because if we're decreasing how much energy, how much food we're having, we want to lose weight, but we want to keep that protein up because the body is going to be burning, but we still want to be fueling it enough amino acids to fuel the muscle, right? This means that individuals on very low calorie diets or calorie restrictive diets should increase their protein intake compared to an individual who eats adequate number of calories. And then the biological value of protein, the higher the biological value of protein, the lower the protein requirement. Now, when I say that, if let's say you have a chicken breast and you have an egg, right, the two most common sources of protein. Let's say the chicken breast has a total of 10 grams of protein, right? Hypothetically speaking. But let's say that the egg has 5 grams of protein, sorry. Which one would be better? Arguably, you would say the chicken breast because it has more protein, right? But what percentage of that protein will be absorbed? That is what we are looking at from the biological value of protein. It's all fair and well that it has 10 grams, but how much of the 10 grams will be absorbed? Now, again, hypothetical situation. Let's say the egg of the 5 grams, your body will absorb 4 grams of protein, right? So of the total protein capacity of that one egg, 4 out of the 5 grams will be absorbed. Right, you guys with me? That is 80%. So 80% of that protein quantity will be absorbed. Let's look at the chicken breast. Your 10-gram chicken breast. You're like, yes, Cameron, I'm getting 10 grams of protein. Okay, what's the biological value? Let's say it is 6 grams. So you're looking at that and you're like, well, it's still more than the egg. You know, it's 6 grams of protein. But that is only a 60% return. Because 6 out of 10 is 60%. Therefore, mathematically and thermodynamically, the egg is a better source of protein than the chicken breast. Because of that total eggs quantity, 80% will be absorbed. Whereas of the chicken breast, only 60% will be absorbed. That makes sense? Yes, Miller.
Question, when you look at both in its entirety, doesn't it, like
Yes.
basic math, obviously for the egg you'll have 4 grams intake, and then obviously for the chicken you'll have 6 gram intake. Doesn't the basic math say that when you measure through quantity measurement, that the protein in the chicken breast will be
It will be more, but what we're looking here is the biological value. So what we are looking here at saying is, how much would you say a chicken breast costs? Let's say it costs 10 Rand, right? You're spending 10 Rand and you're looking at that and you're like, well, I'm getting 10 grams of protein, but biological value is 60%, so I'm getting 6 grams of protein. Now, eggs, let's say 30 eggs are roughly 80 Rand. When 8 divided by 3 is 2 point something, right? So let's say it's 2.5 Rand for an egg, right? or call it 3 rand for an egg. You would therefore need only 2 eggs to reach 8 grams of protein, because it's 4 out of 5 and 4 out of 5. So for a total of 10 grams of egg or protein of egg, you're spending 6 rand to get 8 grams of protein. Whereas if you look at the chicken breast, you're spending 10 rand for a 10-gram chicken breast, but you're only getting 6 grams. So you've spent 4 rand more and you're getting 2 grams of chicken less. You see, this is where nutrition becomes such an interesting topic, because you can look at that and I can say, well, yes, I'm saving money on the chicken, on getting eggs, but we haven't now taken into consideration how much fat there is in the egg now, are we? Because here we're only looking at protein. So do you see how nutrition becomes this continuous, like almost calculation, because you then would then rationalize getting the chicken breast, because the chicken breast will have less fat. And let's say maybe you yourself are a little bit sick and tired of egg, and you maybe want your fat source to be maybe mayonnaise, or you want it to be some avo. So maybe you want chicken and avo, if that makes sense. So now you can rationalize spending 4 rand more on the chicken breast, because yes, you're only losing 2 grams, in terms of the cost point of view, but you can pay 20 rand, you can get 12 grams of protein, and you'll probably enjoy it more. Nutrition isn't just about the calculation behind it, because we can all agree that if just for a day, we could probably eat the most perfect, nutritional, calculated diet on the face of the earth. We could probably do it if we wanted to. But if you're going to tell me to eat buckwheat and quinoa every single day with no sauce and a little bit of salt, I might end up shooting someone, because I don't think anyone will last that long. And that's where nutrition becomes so difficult, because we have this notion in health and wellness that in order for it to be good, it has to taste like crap. In order for it to be good, we have to boil our chicken, and we have to, season it from afar, and we have to almost, like not touch it. It needs to be like a baby's bottom. It just can't be touched, right? And that's where it becomes difficult, because individuals aren't educated on the science of the food. They aren't educated on what we are discussing now. So we focus so much on flavor and so much on the negative, but we're not actually understanding what is nutrition actually doing for us at this present moment. What are we actually consuming? Now, this doesn't mean now that you become like a scientist and you become like overbearing on your nutrition, because that's also not going to do any good. But it's just to understand that some foods have a higher amount of protein that will be absorbed. So then you just don't need as much. But people don't always look at that, because why? Because, you can, I'm sure that we can all agree that probably a pizza or a burger would probably taste better than a piece of chicken or a boiled egg. But what is the nutritional value of that? So it's all these different things which we need to take into consideration before we can start to actively understand how fuel works within the body. Now, when we look at the protein requirements, right? Protein requirements is dependent on goal, but it's also dependent on where you are. Because if you are a normal individual or trying to grow or whatnot, I always say to people 2 grams of protein per kilogram. Don't start to look at this per, how many grams per pound of weight or whatnot, just 2 grams per kilogram of weight. So whatever you weigh, times it by 2, or whatever your client weighs, times that by 2, that's how much protein they should be getting in. Don't worry about 1.7, 1.6, 1.8. Great. that's fantastic for the science and for you to understand that, whether you do general sports activity or strength, or whether you're trying to gain muscle, or whether you are growing, or whether you're pregnant. Granted, all these different ones will have various specific scientific intervals with regards to protein. But at the end of the day, just take your weight, times it by 2, and you should be within a ballpark where you're able to see change with that amount of protein. Now, granted, that is not an exact science. So if you notice that maybe there is too much, so for example, if someone is maybe not seeing the goals that you wanted them to see, maybe you need to increase it. If someone is maybe complaining that their digestion is a little bit off, or maybe they have a little bit of gas, or whatever the case may be, then maybe you need to taper it down a little bit. But you've got to play with that, but always try and give more, because you can always take away. Right? The last thing you want to do is have your clients slanging and banging away, but they are not able to see the results that they want to see in the training, because we're not fueling the body enough to see that change. Would you guys agree? Yeah, see what I'm trying to say.
Totally. Thanks, Cameron. I just wanted to ask a little bit of question. So, if in the course of a weight loss,
yes,
protein is increased, or protein intake is increased, and still there isn't that feasible weight loss, what could that be attributed to?
Well, this is where you guys will begin to notice your relationship with your client becomes so important. Why I say this is because a lot of the time, weight loss isn't just about reducing how much you eat. Granted, that is the most thermogenically calculatable way. If you're burning more energy than what you consume, over time, you will lose weight, right? It's just a matter of maths, right? However, there are certain things in day-to-day life that take that calculation, crumple it up, and throw it away. For example, stress, anxiety, depression, mental health. All these different things trigger cortisol. All these things, if you look at your central nervous system, right, it's broken down into your autonomic and your parasympathetic nervous system. Now, if you have your your autonomic nervous system is broken down to your sympathetic and parasympathetic nervous system. When you look at your sympathetic, that is your fight or flight, right? So that is wherever you guys are sitting now. Imagine I put a lion inside there, or a snake. I hate snakes, right? Or imagine you put a snake in there, right? Or whatever the case may be, whatever is going to make you pray and wish that you were not there, right? That is effectively what stress, anxiety, etc. does to an individual. Now, what happens from a neurological point of view is when you have that, right? Your body can't focus on losing weight. You can be giving your body a rice cake and a kiss on the cheek for breakfast. It doesn't matter what you're going to give yourself. If you are so stimulated from a stress or anxiety or a fear point of view, in inverted commas, it doesn't matter how hard you try, until the brain can shift its focus to what you're doing here. It's not going to be focused on losing weight. Why? Because if it's in that fight or flight, if your brain is in that survival mode, it's not focused on losing weight. It's like, listen here, bro, I want to hold on to as much weight as possible and as much food as possible, because this is a life or death situation. I don't know when I'm going to get my next meal. And even though you're going to feed yourself, that stress and that anxiety is so controlling mentally that you cannot break that. And the only way you can break that is over time, slowly reducing stress, slowly reducing cortisol dumping, because cortisol takes away that hunger, right? Cortisol almost, you feel that stress response, and then you have your dopamine rise and fall, right? Because you have that flight or fight response. all of a sudden you feel on edge and you're ready to go, and all of a sudden you have that dump, but your body's not focused on losing weight. Your body's trying to keep all the nutrients to itself. So there could be those other things in an individual's personal life that they aren't necessarily telling you. Another case could also be when people get stressed with their overall image, they may also be taking, for example, laxatives. It's become very common. And all of a sudden, all the food that they're eating, even though you're increasing that protein and you're decreasing the weight, all they're doing is it's just being filtered and flushed out. So whatever the body is trying to hold on to, it's trying to hold on to more water because they're becoming more dehydrated. Water adds that weight. All of a sudden the foods that you're getting, need something to digest. So then they're sitting in the gut for a little bit longer because there's all that bacteria is being flushed out from a laxative point of view. So there's all these different things, that can be looking at that. But there is also the straight up possibility that maybe then, you do need to decrease some of the protein. If you have increased it a little bit because you're accounting for the drop in carbohydrates and the drop in fat, because most protein sources are quite good in fat content as well and a little bit of carbs. But let's say you then are at a point now whereby, okay, cool. I know that we've got to your protein amount per day, but we're going to slowly start to taper that down and see what works then. But for most people, you can see changes within a week, but always give it an element of time. You need the chance for the body to adjust. You need the body needs to be able to realign itself, etc. And you really need to be able to take that forward. Okay, and that's what I want you guys to understand. That's what you have to understand, guys, is that you're working with people. There's a hell of a lot of stuff outside. For example, Emmanuel said earlier, right? He would appreciate a week's notification. Received at about 1 p.m. yesterday for the email, right? Because he was busy with month-end reports. How many of us have had to deal with BS in our life? Be it a boss, be it day-to-day life. I'm sure we can all raise our hand and say we've had a bad day, right? On those days that you've had a bad day, how many, if you're really stressed or you have a meeting there that you need to go into, how many of us actually enjoy eating before we go into that meeting?
I
don't.
know I don't.
I don't. I don't want to eat.
I don't.
Yes, he said so. You can unmute yourself. I can unmute
Oh,
you.
sorry. No, I was just saying I
No.
enjoy eating before the meeting.
You enjoy eating. You're brave. You're brave. I don't want to. I don't want to eat anything before I go to the meeting. I almost like feel, that feeling you're about to feel before you like go on a roller coaster, or when you're driving on the road and you feel your stomach come up, right? But you see, you there sits, you're different, right? Now imagine if we took how Emmanuel and myself felt, or I saw Melo nodding his head, maybe he feels the same. Now all of a sudden we applied that knowledge to everyone. How unfair would that be to you? Now all of a sudden I'm training you, but just because I trained Emmanuel and Emmanuel doesn't like to eat, now all of a sudden I tell you not to eat too. But you're like, hang on, Cameron, I actually prefer eating. That little bit of food or that little bit of energy actually helps calm me down. So do you see how this whole nutrition thing becomes not just a copy paste and there you go? And this is what I want you guys to understand, right? If we want to have a financial conversation here, how would you like to be charging your client 200 Rand an hour? Right? I'm pretty sure most people would like an extra 200 bucks an hour, right? It would be great. Or would you like to charge your client 1,000 Rand an hour? Right? What I'm trying to say here, it's not always about how much you're going to charge. But if you can provide that value, if you can provide that approach and stand back, put your shoulders out and say, you know what? I know there's going to be other people, but what you're going to get from me is you're going to get the best damn quality that you can possibly get, because I'm going to put you first. I'm going to show you what quality is. right? And you're going to personalize it, guys. And that's what I want you guys to see. This isn't just about doing this course so we can all smile and wave and you can get your certificate and be like, hey, look what I did and whatnot. You want to change your life, right? But in order to change other people's lives, you have to change your own life first. You have to be able to see the value in yourself before you can take that value and give it to other people, right? So when we go through all of this, this isn't just about me telling you what the protein requirements are per kilogram of body weight. Your clients can go and Google that on ChatGPT. But if you're able to take that and break it down and explain to them why this is the value that they have, they are investing in that value. Because if it was that easy, why wouldn't everyone just go and download MyFitnessPal and Hunky Dory and off we go? Because people are looking for affirmation. People are looking for that almost, you know, acknowledgement of knowledge, or that acknowledgement that what they are doing is right. But how are they going to know what they're doing is right if we do not provide them that value, if we do not show them that what we are saying has an element of backing? And the only way we can start to do that is, yes, you can send them all the research in the world. I work in a research space, right? I work with neurosurgeons, right? But do you think the individual that comes in with a stroke or with a brick there that's been hit over their head or whatever, do you think the individual really cares what the study said about 2 years ago? No. But the individual is going to care how we can take that information and apply it to them and explain it to them in a way that they can understand. It's the same with nutrition. If the individual doesn't understand the importance behind why chicken is a better protein source than, for example, pork chops, do you ever think the individual is going to buy the chicken over the pork chops? No, because they're going to be like, to hell with your opinion. I like pork chops. I like pork chops. I want my pork chops. But if we don't explain the value, then how can we empower our clients to be better? So this is where this whole thing comes in. And here we're just looking at nutrition, but it feeds so many different things, right? It's like some people say the way to a man's heart is through food, right? Now, if you look at food, food isn't just about, like we said, health and wellness. Food has an element of emotion to it, right? Think about, be it a braai or whatever the case may be, a family gathering or whatnot. A large portion of those family gatherings is food, right? So we're not here to demonize or bastardize food, but we're here just to increase our knowledge. We're here just to help people understand so that they can take that information forward and apply it in their life. You can apply it in your business, you can apply it in your service offering, but it all starts with value. And you cannot show value if you do not understand. Does that make sense? And that's where training needs to be changed, and that's where we need to look more with regards to nutrition, so that people can make better choices, so that people can be healthier. Because if they feel good and then they look good, that carryover will not just be in their training, but it will be over into their family life, into their work life, etc. And it all starts with the brain. But how can the brain function effectively enough, ladies and gentlemen, like we said earlier, if it isn't fueled properly? So it's all fair and well. We can buy the Ferrari, right? We can have the Ferrari. Oh, bugger, sorry. We can have the Ferrari, but how can we drive it effectively if you're giving it subpar fuel? You'll get 2Ks down the road and you're going to blow a gasket or whatever the case may be, right? What's the point then of having a Ferrari if you're not going to fuel it efficiently? Same thing with nutrition. Same thing with everything. Everyone has a different life. Everyone has a different approach. Everyone has a different story. That's not for us to look at them and try and put them in a box. It's about looking at individuals as individuals and helping them walk along their fitness journey as best as possible so that they can see more value in themselves than what they did before. That's really all that we do. Any questions before I go on to the next point? Yes, Miller.
Yes, no, I just wanted to ask, based on for instance, the grams, the 1
Yes.
kilogram for
Yes.
for instance, general sports, is this based on the fact of the basic requirement to stay alive per day, or is it based on the requirement for one to bulk up or lose weight, just like the essential?
This is the minimum effective dose for performance function, if you want to call it that. So what we're looking at here is if you are someone who partakes in general sports activity, the protein requirement per kilogram of body weight to function effectively should be 1 gram per kilogram. It's not just to survive, right? This is just if you want to maintain that element of performance. For example, if you look at strength training athletes here, one individual is trying to maintain. So based on science, to maintain your muscle mass and not lose muscle mass, you need to have 1.2 to 1.4 grams per kilogram. But all of a sudden you see if you want to gain muscle mass as a strength training athlete, science says that you should have 1.6 to 1.7 grams. So it all depends on where your performance is, right? And that's where it all depends on what you want out of it, really.
Is this within a specific allocated day, or is it like post workout? For instance, if
This would be throughout the day. Because remember, this would be over a day, right? Because performance isn't just when you're working out. Performance is before you perform, after you perform, and a large portion of nutrition for your performance today was consumed yesterday. This notion that what we ate an hour before we're going to train is directly influencing our performance is not really true. And what I mean by that is I'm not saying that your pre-workout meal is not contributing to your workout. That is not what I'm saying at all. But if you think that you are getting enough in that 2-hour window to facilitate the whole rehabilitation, the whole muscle protein synthesis, the whole recovery of that one workout, I'm pretty sure we can all come to the conclusion that that is not going to be very accurate, right? Because once your body uses all of that you've consumed in the past 2 hours, right, pre or post workout, is that all we need? If it was that easy, we'd all then just eat before our workout and after our workout, right? But it's what you fueled the body with over a period of time, ensuring that you have fuel. For example, again, using a car, you need to make sure that you have fuel in your car to get from A to B, right? But in order to ensure that your car functions properly over a period of time, we always have fuel in the fuel tank. We're not going from 0 to 0 every time. We're not putting in just enough fuel so that by the time we get from point A to point B, as soon as we get to point B, our car turns off because we're out of fuel. How many times do you think you'd be able to drive your car like that before your car packs up? Because it's going to continuously be running on empty. It's going to continuously be just running on empty, running on empty, running on empty. The same thing with nutrition. It's over time how you treat your body and how you fuel your body, which will result in the efficacy of functioning of your body. Does that make sense?
Yes, I think it does. But just the one last question that I wanted to ask.
Yes, yeah, sure.
Say for muscle gain on 1.6 to 1.7, it
Yeah.
come from the divide of you having to factor in dividing 1.7 and then having specific time frames during the day of like I'm gonna at 6 o'clock I'm gonna have like 0.8 grams of protein, and then
This-
at one.
So this isn't just saying 1.8 grams of protein. No, this is saying whatever your weight is in kilograms, you're going to times it by 1.7. And that is how much you're going to have throughout the whole day. So whether you want to have all that protein in one meal, which will arguably be very difficult, but if you wanted to have that in one meal, then you can have that. But if you want to separate it into 4 different meals, then you can separate it into 4 different meals. Then there's not just like, right now I'm going to have 1.8 grams of protein. It's throughout the whole day. So for example, if you took 100 kilograms and you times it by 1.7, that would be 170 grams. right? So that 170 grams for 100 kilogram individual is you take that 170 and you could then break that up into a meal of 50 grams, a meal of 50 grams of protein, and 2 meals of 35. So you can have 35 grams of protein with your breakfast, 50 grams pre-workout, 50 grams post-workout, 35 grams dinner. For argument's sake, you could do that. Or if you're only eating 3 times per day, you could have 1 meal with 100 grams of protein. Let's say you're going out for dinner, right? And you get a nice big steak. You get 100 grams of protein in, and then you had your breakfast. You had 35 grams of protein, and for dinner or for lunch or whatnot, you had another 35 grams of protein. But it's all just you take that net amount and then you divide it accordingly.
Oh yeah, nah. I just realized that I didn't see the grams and the kg kind of threw me off because usually I
No,
think
no worries.
it's per
No, you guys,
per
you got to
per
ask questions.
kilogram and then you times it. So I
Yes,
overlooked
yeah.
that part. Hence, I was like
No,
asking
no,
it
it's
didn't make
no, it's
sense.
completely understood. Completely understood. Sorry, it's not necessarily the most legible table. I got that out of a textbook. But anyway, guys, for the sake of time, I do just want to crack on. But does anyone need the bathroom or anything like that? I know that we've been going for more than half the time. Does anyone need to go to the bathroom or anything like that?
I'm good. I just wanted to ask
Yeah,
Cameron, I see you're recording this session. Is it going to be
yeah,
available for some
yeah,
review
yeah,
afterwards?
yeah, yeah,
Oh, okay, great, great.
yeah.
No, thanks, man.
So
Thanks, man.
afterwards, the recording will be saved, and then I email it to admin, and then they send it to you guys.
Awesome. Thank you so much.
Yeah, cool beans. But if you guys also want the slides, you're welcome to email me after the lecture or whatever the case may be. If you need the slides, and I can also send them to you guys if need be.
Oh, that would be awesome indeed. I think the slides would do justice.
Okay,
Just
no
sitting and
worries.
watching. We still
No,
used to reading and studying.
no, all good, all good. All right, guys. Now crack on. So then you also get the different types of vegetarians because most of the time, some people who are anti-meat. Just to run through these very quickly, you get vegans, whereby no animal products, so food of plant origin only. Sorry, you get lacto-vegetarians, so lacto meaning milk. So these are plant-based diets with milk. You get ovo-vegetarians, so ovo meaning eggs. These are individuals who eat plant-based diet with eggs, no dairy. Then you get lacto-ovo-vegetarians, which are eggs and milk, therefore plant-based diet with eggs and milk. Then you get your pesco-vegetarians, so meaning fish. These are your lacto-ovo-vegetarian diet with the addition of fish. This excludes chicken and red meat. You get polo-vegetarians, polo meaning they eat chicken. So you get this is your lacto-ovo-vegetarian diet with the addition of chicken. This excludes fish and red meat. Now, animal foods are a good source of many important vitamins and minerals. Thus, nutrients, sorry, are most likely to be lacking in strict vegetarian diets, which include iron, calcium, riboflavin, zinc, and vitamin B12. These are all because in some of these diets, as I said, meat. If you think of animals consume different sources of nutrients, and those nutrients also and those vitamins get stored in that meat as well, from their overall functioning, and that's where we also get a lot of our vitamins and minerals from as well, right? Like we also eat different greens and whatnot. When we also eat the meat, we're also getting an element of that nutrition, from the animal as well. Okay, and that's where we do need to look at this more from an overall point of view and not just a person-to-person view. Now, food combining rules for vegetarians, if you look at some of these, this is just for general knowledge for you guys. They can have various different legumes or peanuts and grain products. So legumes being beans, split peas or lentils. And this is how you can combine some of them. If you guys do have clients who are vegetarian or whatever, you can give them sampan beans, rice and beans, peanut butter and brown bread. You then also have legumes or peanuts with seeds or nuts. For example, you can make a hummus. If you're looking at grain products and dairy products, you can think of meals like a macaroni cheese, a whole grain cereal and milk, cheese and crackers, or biscuits or whatever. And then some of the nuts and seeds with dairy products, for example, you can have your yogurt with sunflower and pumpkin seeds, or some individuals like yogurt and granola, and all those various different things. But these are just some meal ideas which you can just use just for general knowledge, as I said, or you can use them if you have a client who may be vegetarian as well. This is how you can combine some of the things together. If we look at the classification and structure of protein, now this is the actual protein structure, right? Now, proteins are a complex molecule made up of smaller subunits called amino acids. So amino acids are the building blocks of proteins. From a functional classification, amino acids that are synthesized in the body in adequate amounts are termed non-essential, right? Non-essential, meaning that the body makes them. Essential, important, meaning that you need those amino acids supplied by nutrients. So you have to ingest food that is going to be rich in those amino acids to give your body those amino acids. Whereas for the non-essential ones, your body makes that on its own. Yeah. Those that cannot be synthesized at all in the body or that are synthesized in inadequate amounts are termed essential because they must be supplied by food sources. Of more than 20 amino acids that have been identified, 9 are considered essential, 8 in adults. And here we can see that, for example, 9 essential amino acids and non-essential amino acids. So all of these non-essential amino acids, if you look at my little laser here, all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all of these different ones, right, are made within the body. All of these that are essential, we need to eat foods that are rich in these to ensure that we get these. So when we look at our overall body functionality, we have a full amino acid profile so that should the body need lysine or methionine, that it has that. And should it also need glutamine or proline or serine, the body has that, right? But the only way you can give this full amino acid profile is if you consume a well-balanced diet, which is going to fuel you with those required amino acids. Make sense to everyone? Sure?
Yes, it does. Yes, it does.
Okay. Cool beans. Now, when we look at this, now remember how I said too much of a good thing can lead to a bad thing, or too little of a good thing can also lead to a bad thing, right? Now, if we look at too much, if you have too much protein, right? So this is you're looking at more than 4 grams per kilogram per day. So if you're a 100-kilogram individual, this is more than 400 grams of protein. Now, granted, this doesn't necessarily apply to bodybuilders because they are a completely different kettle of fish when it comes to this, right? Because they are slightly different, and the same with high performance athletes. You may find swimmers or endurance athletes which are eating so much protein, but they're also burning so much protein, right? It will still play a somewhat of an effect, which is why if you look at most bodybuilders, often in time they end up having quite bad kidney issues, right? And that's because of various other things, but also how much protein they also eat. Now, excuse me, should you have too much protein, what can it lead to? Well, it can lead to ketosis, dehydration, calcium loss, gout, possible stress to the kidney, cancer, depending on the source of protein, and liver, and it can affect liver and kidney function. However, if you have too little protein, this can lead to kwashiorkor, marasmus, physical and mental growth or retardation. Some of it can become permanent. You can have a decreased peak bone mass and a decreased immune function. So you see how if you have too much, the various different things that can be a result, but also if you have too little, the various things that can also be a resultant of. And that's why, everyone talks about a balanced diet, but that's why working towards a balanced diet will arguably yield the best response possible. Would everyone be on the same page here? Yeah, I was ready
Got
to
it.
move on. Yes, Miller. You are still muted, Miller. If you just unmute yourself.
I just wanted to ask what then becomes the the protein grams for?
Sorry?
You said like for the bodybuilders, the grams in terms of like the protein intake becomes higher. I just wanted to know what's the figure for the bodybuilders. Yes.
Now, that's a person-to-person thing. There's no specific. It would depend on really what the individual. Some individuals can function on 1.5 grams per kilogram because they just function better like that. And that's where it goes back to that individualizing of the diet. Rule of thumb, I would say start with 2 grams per kilogram. Rule of thumb. Start with 2 grams per kilogram and just see what happens. Arguably, more often than not, and this goes with supplements, etc., people actually need less than what they think because they always think that more is better. But you can clearly see based on this slide that sometimes if you do push that needle too far, right, you can also start to get various digestion, dehydration, and overall liver and kidney function issues. Excuse me. Everyone see that? Cool. Now, what about fat? Well, if we move on to fat, fat is critically important macronutrient as it is concentrated form of energy with 1 gram of fat supplying 2 times the amount of energy than glucose as well as protein, 9 calories versus 4 calories per gram. Fats form part of membranes such as lipoproteins, including the skin, brain, and nerve tissue, and provide insulation. The functions of dietary fat are responsible for the satisfied feeling after eating, so that's the satiety sensation, reduced rates of gastric emptying, so this leaves the stomach more slowly than carbohydrates or proteins, which is why often if you have, for example, eggs in the morning, you'll feel slightly full for longer as opposed to, let's say, if you just had some protein or some carbs, because it's going to take longer to digest that protein, so you're going to feel fuller for longer. Oh, sorry, that fat, sorry. It's going to take longer to digest that fat. The primary function of lipids is to provide a concentrated source of energy, so the transport of fat-soluble vitamins, insulation of and cushioning of organs. They form part of the membranes. They aid in the insulation of nerve cells, such as the myelin sheath. The maintenance of the menstrual cycle or estrogen, which is essential in activating osteoblasts, and then it is also required for the formation of steroid hormones such as testosterone, progesterone, and estrogen, sorry, and progesterone. Now, when you say that and you're like, okay, cool, I didn't know that they were involved in hormones. Yes, cholesterol is very important because those hormones, testosterone, estrogen, and progesterone, are cholesterol based, right? So they need that fatty group to bind to generate that hormone. Right. Now, the structure of fats. So they have a basic structural unit, which is a fatty acid molecule. Fatty acids are either saturated or unsaturated. Saturated fats are those in which all chemical bonding sites are filled. Unsaturated fats have some unfilled bonding sites. I'll show you guys further down the line. And they can have 1, 2, or more bonding sites, meaning they can be mono unsaturated or polyunsaturated. So if you look at that, if you have, various different saturated fats or unsaturated fats, I'll show you the difference between mono, di, and polysaturated or tri-saturated fats. Now, unsaturated fats are liquid or soft at room temperature, such as oil or margarine, and saturated fats are solid at room temperature, such as lard or butter. Animal products, are high in saturated fat, whereas vegetable fats are high in unsaturated fat. So you can look at that and note which ones have been produced more often than not by animals and which have been produced more by plant-based origin, just by their form at room temperature. So when you're walking through the shop, through Pick n Pay, Spar, Checkers, you name it, if you look, for example, in the oil section, you know that oil has an element of fat, but you know that that is most likely produced by a plant. Why? Because it is liquid. Excuse me. If you look at, various other products, you can see what has come maybe more from an animal origin, because maybe they are more solid at room temperature. Yeah, so it's also stuff that you can start to look at. You can start to, what's the right word? Apply just in day-to-day, generalized shopping, or whatever the case may be. Now, if we look at saturated fat, here we're looking at the animal sources. This is like fatty beef, mutton, lamb, duck, all with fat, processed meats, chicken and turkey skin, full cream milk, yogurt, cheese, butter, cream, ghee, chocolate, takeaways. Vegetable sources are coconut and palm kernel oil. If we look at more trans fats, these are biscuits, pies, pastries, cakes, crisps, samosas, sausage rolls, pretzels, hard bricks of margarine, deep fried and battered food. From a cholesterol point of view, here we're looking at more organ meats, so offal, brains, liver, kidneys, egg yolks, shellfish, looking at those prawns, shrimps, calamari, and crayfish. Then if you're looking at more of your mono unsaturated fats, right, they're looking at your olive oil, peanut oil, all of those different ones from a more of a plant origin. Your polyunsaturated fats, you're looking at more of your omega-3, 6s, and 9s. You're looking at your alpha-linoleic acid. So dark, oily fish, you're looking at more of your salmon and your mackerel. Now, when we say dark, oily fish, we're not referring to how it is cooked, but we're more referring to the actual color of the meat. It's a color, or it's more dark than, let's say, like hake, which is quite light. And then nuts and seeds. You also look at omega-6, which is linoleic acid. So you're looking at more of your soft tub margarines, low-fat spreads, mayonnaise, etc. That's why if you look at Flora will often say that it is rich in omega-6, right? And it has the big heart on it, and you have Flora, and it says rich in omega-6. Well, now you can see why, because it is soft at room temperature. Why? Because it is an unsaturated fat. So you see how now you can start to gauge why different things are packaged the way that they are packaged, and the overall nutrition behind it. And then now when we look at labeling further on, you'll be able to now tie all of that together, because you now understand what a fat is. You know that you have unsaturated fats. You know that leads to more plants. You know that the label's saying this, etc. And then you can start to generate that value. Okay. Now, I said I would show you what these are. Now, these are the different types of fatty acids. So remember, we said saturated. So there's no bonds. You see, it's all single lines. Now, all of a sudden, you have mono unsaturated. Mono meaning one. And you can see there's one double bond. Then when you have polyunsaturated, it's more than one bond. So you can see there's two double bonds. Now, in terms of energy to break down, this is why saturated fats are easier to break down, because you see all you need to do is break one bond there, one. Whereas here with just at the mono, it takes more energy to break that double bond. But even more so at polyunsaturated, it takes even more energy to break these two bonds in terms of digestion, because there's more to break here. So you can slowly see how and why different fats are sometimes make you feel fuller for longer, and why sometimes they are so difficult to burn. Okay, because it is of the bonds. Right, any further questions on the fats?
Got it. Understood.
Okay, all good. Anyone else? No. Okay, guys, what I'm going to do is we're going to go through carbs, and then what I'll do, I'll give you guys a quick 5-minute break before we go on to micronutrients. And then once we go into micronutrients, then it will be relatively straightforward And then we look at the overall energy balance, the different food groups, the labeling, and then we'll be done for today. Okay. I do know that it is a Saturday, so I do my best to not to dawdle, because I know that you all have loved ones, you all have family, etc., etc. So we will be finished by 12:30, but I do try and take into account that you guys are sacrificing time with family as well. Okay. So if we look at carbohydrates here, carbohydrates are found in all starchy and or sweet foods. Here you can look at rice, pasta, potatoes, cereals, legumes, bread, cakes, etc. You can look at cola, you can look at beers, you can look at dried fruit, fresh fruits, vegetables, desserts all contain a high percentage of simple sugars. And that's effectively what a carbohydrate is. It is sugar in its by definition. And or sugar by definition is a carb. And you can also look at milk and its products, and then they contain lactose, which is a type of carb. Now, function of carbohydrates, they are important for energy production. That's what we need to think. They are the first, as we mentioned earlier, the first thing that is going to give you energy. Now, they are stored after your ATP and creatine. Now, they are stored in the muscles and liver as glycogen. The brain requires a constant supply of glucose as its primary fuel source. They can be converted into fats and proteins if the need arises, and only non-essential amino acids may be produced from glucose. The essential amino acids need to be ingested. So you can see now how we spoke about those non-essential amino acids. If you recall, non-essential meaning that the body makes them, but you can see even though the body makes them, you still need to consume glucose. Why? Because here it says only non-essential amino acids may be produced from glucose. So in order for your body to produce those amino acids, you need to be consuming an element of carbohydrates. So do you see how the body works together? You can't just remove one and have the other. You can't have your cake and eat it. You need to be able to think about this. And that's the same that comes with creating meal plans and that for clients, is that we're very quick to take stuff away, but what is that consequence? What is the long-term consequence of that decision? Right. Monosaccharides are single simple sugars. So this is, for example, we're looking at glucose, fructose, and galactose. So glucose found in table sugars and fruits. If you look at fructose, this is found in fruits and vegetables. And if you look at galactose, this is found in milk. Now, when we look at these, they can further be broken down into, for example, disaccharides, which are when two monosaccharides, are chemically bonded together. So mono meaning one, di meaning two. So this is a two sugar chain or a one sugar chain. If it's just one sugar, then it's just going to be fructose or glucose or galactose. But when we combine them together, you take a mono and a mono becomes a di. So one and one is two, right? So one saccharide, one saccharide makes two saccharides. Therefore, disaccharide. Right? And then if you get more than two, then it is now poly, because there's more than two. You guys keeping up with how we determine these sugars. Now, so sucrose is the resulting sugar of one glucose and one fructose. So you get sucrose. So, and this is common table sugar, brown sugar, syrup, and molasses. Then you get lactose. So this is one glucose and one galactose creates lactose, which is the main sugar found in milk. And then you get maltose, which is one glucose and one glucose. So therefore, two glucose is found in cereals and beer. So if you take two glucoses and you put them together, they create maltose. If you take one glucose and one galactose, you put them together, you get lactose. If you put one glucose and one fructose together, you get sucrose. So you see how it's just showing you that overall formula. Now, polysaccharides are a long chain of many monosaccharide units. So if you almost think of a chain right? It's all one link, two link, three link. Eventually, you have a whole long chain. That is what a polysaccharide is. They are often referred to as complex carbohydrates in contrast to simple sugars. Why complex, right? Because there's more of them, right? So if there's more of them, for your body to break it down, it's going to take a lot longer, right? That's why some people say eat complex carbs, slightly more complex carbs, because you'll feel fuller for longer. Whereas if you eat more of those simple sugars, that's why you want more. Then that's why when you have a cake or something like that, it's all those simple sugars. So they give you a state of satiety, but then they make you want more and more and more and more and more because you're never really feeling full because you're digesting it so quickly. Whereas if you have something that is maybe more of a polysaccharide, it's going to take your body and your stomach longer to digest it. Therefore, you'll feel fuller for longer. Most polysaccharides are of plant origin and are commonly known as starches and fiber. The most abundant polysaccharide is cellulose, which the human body cannot digest and is more commonly referred to as fiber. Not the internet, but the food. Okay. And here is an image to depict how this looks. So there you have your three building blocks. You have the glucose, you have the galactose, and you have fructose. You can see their chemical structures here. Now, you get, if you take one glucose and one glucose, so you can see the chemical structure there, and you join them, this becomes maltose. If you take one glucose and one fructose, you get sucrose. And if you take one glucose and one galactose, you get lactose. So here you can see how they bind and how they will effectively be at their chemical structure point of view. Any questions?
So far, so good.
Thank you, Melo. Melo, no questions on these? Okay.
No, not just a quick thing. What will happen if you combine glucose, galactose, and fructose?
But then it would create a polysaccharide because you'd have three sugars then. So you'd have three building blocks. Yeah.
Galactose and fructose.
Yeah. So you could take lactose here, and then if you combined it fructose to that, then it would create its own polysaccharide. Boom. Polysaccharide, more than two. All right, guys. We have micronutrients, which we'll go through. But what I want you guys to do is just quickly stand up, have a quick walk, grab a glass of water or something like that. Just stretch quickly, and we'll continue in uh, let's say 25 past, so in 7 minutes time. So and then we'll smash the next part of it up. But just quickly stretch your legs, do what you need to do, just shake everything out, and then we'll smash the second half of the lecture quickly. Right. See you guys now. Just stretch and do your thing. Right. Everyone ready to crack on? I need some time. Emmanuel, I'm just waiting for Melo to give a thumbs up. Just make sure that he's back. You guys have any questions on the first part or anything that they don't have to necessarily be topic related? Yeah.
No, I think for me it's been quite insightful. I've got to meet a couple of high performance athletes and well beginners, alike, and it's clearer now in terms of what I've got to experience with them when it comes to their
Mm,
progress, fitness related, and of course their nutrition as well. So I mean, something that makes me laugh every now and again is there's this bodybuilder that I know, who prefers to have, and this is quite funny for me, have a meal of pop
mm,
and meat before an hour before coming in, and he's able to really push himself,
yeah.
in comparison to the days that he doesn't even get to eat anything when he comes through. But for him, it always has to be pop and meat.
Yeah, and that's what you'll find is that everyone's different. Like some people aren't able to eat before they train. Other people are.
True,
And that's
true,
what's
true,
so
true.
interesting about when it comes to nutrition is that some people you cannot apply one rule to all. Some people
Mm,
will be able to perform better. Some people have to eat before they train legs. Other people prefer not to eat
that's right.
before training legs. Some people want to have an empty stomach. It all really depends on what you're going for, right? Um,
Mm,
and that's where it becomes quite interesting and getting to know the person. A lot of the time people view
that's
training
right.
as just like, okay, cool, we're starting at 3, we end at 4. I just want to make you sweat as much as you can and feel like you've been hit by a truck, and then you go home and then you
Yeah,
repeat tomorrow. There's a lot more that
yeah,
that comes with the territory.
absolutely. No, I totally agree.
All right. Perfect. Now let's get to the next topic, micronutrients. So vitamins are organic chemical compounds, minerals are trace elements, are inorganic compounds. Collectively, these compounds are called micronutrients and are essential for many biological functions. They serve as regulators and links in the processes of energy released from food, and they are important cofactors in various chemical reactions, and as such are important in maintaining homeostasis, so relatively constant internal conditions. To the general public, vitamin intake is synonymous with good health. Folic acid prevents birth defects, and vitamin E protects the heart. Some of the minerals are also believed to have a strong association with health, calcium, and helps to prevent osteoporosis. Each vitamin has its own specific function and cannot be replaced by another vitamin. And that's also very, very important when it comes to vitamins. Is that well, what people forget is that if I just take this, it will help me with that. Not necessarily. If your body needs a specific vitamin, you have to get that specific vitamin in. The problem that people have is that they generalize it. So they just take a multivitamin and like, okay, cool, I'm taking my multivitamin. It's not always the case. That multivitamin is just to make sure that you meet the basic threshold for basic functioning. But if you have a specific deficiency, you cannot just take a multivitamin and be like, cool, I'm fine. And of that, you cannot just take the required dose that it says on the capsule bottle, because you may need more or less, or maybe the actual capsule may not have the right amount. You need to also read the label and see what is that actual dose, because you may be taking, no, I'll take 1 capsule a day, but to reach that dose that you need, you may need to take 3 capsules a day. For argument's sake. So it's all those things are quite important to take notes of. Okay. Moving on to vitamins. They are considered essential nutrients and as therefore must be obtained from the diet, except for vitamin D, which can be synthesized from sunlight, and vitamin K, which is synthesized by bacteria in the intestines. That's why also sunlight's so important to get. Vitamins are present in all foods in varying proportions and concentrations depending on the foodstuff. When a vitamin is absent from the diet, a deficiency may develop within 3 to 4 weeks. Vitamins are divided into two groups depending on their solubility. So you get fat-soluble vitamins and water-soluble vitamins. The easiest way is to know fat-soluble is ADEK, A-D-E-K. This group includes vitamins A, D, E, and K, all of which are dissolved and stored in fatty tissue, hence they need to not be taken in daily. As they are stored in the body, there's a danger of excessive intake, which may ultimately become toxic. Small amounts of these vitamins are excreted in the bowel or absorbed into the lymphatic system. Deficiency symptoms are slow to develop. Why? Because they're that fat soluble. Remember, they take longer to break down. Water-soluble vitamins, on the other hand, this group includes the vitamin B groups and vitamin C. They are transported in the bodily fluids because they are not stored daily. And daily intake is essential, sorry. Excesses are usually excreted in urine. Deficiency symptoms often develop rapidly. So, you need to look at this whereby you need to think what do you need to get in, where you're going to get them in from, and that's why if we understand what they are, we can then apply that a lot better. Makes sense to everyone. So that's why nutrition becomes a multifaceted approach. In general, vitamins have these three functions. They're essential for physical, emotional, and mental functions. They're essential for growth, and vitamins are intimately involved in enzymatic reactions and are essential to produce energy from carbohydrates, fats, and proteins. If we look at minerals, minerals can be divided into two categories. You have macrominerals requiring daily intake of more than 100 milligrams or presence in the body in amounts greater than 0.01% of body weight. You have microminerals, so these are more of your trace elements. This requires a daily intake of less than 100 milligrams or presence in the body in amounts less than 0.01% of body weight. None of the minerals can be synthesized in the body and therefore must be taken in daily. Minerals are readily available in food, so supplementation is not always necessary. Deficiency symptoms arise from lack of minerals, but a high intake can result in toxicity. So it's just finding that balance. Like I said, too much of a good thing can become a bad thing, and too little of a good thing can also become a bad thing. So you don't want to be deficient, but you don't want to have so much that it creates a toxic environment for your body. And that's when people start to have adverse effects. They begin to have digestive issues and all of these different things. So it's really just about making sure that you can get in an adequate amount to ensure that your functioning is not just met, but it can also be optimized. Now, if we look at minerals, although the functions of minerals are numerous, they have four major functions. So they provide structure for the bones, they regulate cellular metabolism, and they are involved with muscle contraction and nerve activity. They play a role in acid-base reactions as well. And here's a nice diagram that I will get for you guys so you guys can see. So if you look at from a vitamin point of view, you can see how there you have the breakdown of water soluble to fat soluble. And as I said, fat soluble is ADEK. And then, of course, water soluble, you can get via vitamin C or your vitamin Bs. And you can see all of that there. So you can see there's a nice breakdown, especially if you're prepping for an assignment or whatnot or a test. You can then be like, okay, cool, vitamins. You get fat soluble, water soluble, fat soluble. I know that's ADEK. If you look at water soluble, there's vitamin Bs and vitamin C. So there's vitamin C and then all the Bs. And then you can just go about that. So then they can ask you a question, for example, which of the following are water-soluble vitamins? And they can say vitamin C, and then they can just say, for example, folate and vitamin D. So you will need to be able to know that folate is one of the vitamin Bs, but you could do from process of elimination that it would be vitamin C and that folate, but it wouldn't be vitamin D because you know that fat soluble is ADEC. Does that make sense to you guys? So do you see how simple vitamins and minerals are, but how important they are? Like, look at all these acid-base reactions. Look at all the nerve activity, muscle contraction, cellular metabolism, structure of bones. So the micronutrients really are the currency of performance, right? If you cannot ensure that your body is moving through those acid-base reactions properly at a cellular level, at a nutrient level, how do you expect to function at a macro level? You know, so it's all in the finer details initially, and then you can move up. Any questions on vitamins and minerals? Cool. Now,
All good.
Now, if we look at, so what we've done now is we've gone through the macro, we've gone through the micronutrients, and now what we're going to do is what does this mean from an energy point of view, right? Because we know that proteins are 4 calories per gram, we know that carbs are 4 calories per gram, and we know that fats are 9 calories per gram. Now, we've also gone and we've seen with regards to micronutrients, the importance of vitamins and minerals. But what does that all mean from an energy point of view, right? So if you look at this, you have an energy balance equation. So the energy balance equation includes terms that refer to energy intake and energy output. For some individuals, the equation must also include terms for energy required for growth and activity. But in this case, you have your energy in, so what you consume. Energy is available from the food and liquids we consume. The energy we consume is represented by energy in, right? This energy is derived from food, commonly described in kilojoules or calories. A food calorie, there's the relation there, is 4.18 kilojoules or 1 kilocalorie, also just kcal or calorie, capital C, calorie, is defined as the amount of energy required to raise the temperature of a liter of water by 10 degrees Celsius at sea level. Now, you may need to know that definition for a test, but all that we're saying there is 4.18 kilojoules, kJ, is equal to 1 calorie, 1C or 1 kcal, 1 kilocalorie, right? Now, that is more towards what we're going to be looking at, but what does that mean from an energy point of view? That is the amount of energy that is required to raise the temperature of a liter of water by 10 degrees Celsius at sea level. That you'll just need to know for merely definition purposes, but not actual functionality purposes. A food calorie is the equivalent of 4.18 joules to calculate the kJ, the kilojoules per calorie, which is often a capital C, as I mentioned before. So these are all just the various different maths equations, but they are very well explained in your textbook, but it's just more for you to understand. You could get a multiple choice question. You could potentially get a quick definition question out of this in terms of, you know, what is the value of 1 kilojoule or 1 calorie? You can say 4.18 kilojoules, etc. Please take note of the units, kilojoules, kilocalorie, 1 kilocalorie, 1,000 calories. So please take note of what the units of measurement are so that you do not lose pointless marks for not giving the adequate measurements. Now, then we also have energy out. So energy out is the amount of energy we expend and represented as E out. And E out has 3 major components which added together can provide an approximate measure of an individual's daily energy needs, such as your BMR, physical activity, the thermic effect of food. And all of these will give you your daily expenditure of how much you're going to expend. Now, when you think of that, it shows you that that's why you can eat what you maybe are prescribed and still lose weight, because you're not just looking at your gym session and how much you eat. Because if we had to look at that, imagine how long you would have to train for to burn enough energy to eat the amount of food that you want to eat. But there's more ways that we burn energy apart from just physical activity. You have your basal metabolic rate, so just the natural metabolism of your body burns energy. And then you also have the thermic effect of food. Eating food, right, and the digesting of the food, etc., has its own energy requirement. So you add all of those up together, and then you'll get to a rough estimate of how much energy you burn on average a day. Then all you do is you take that amount, you subtract 500, and then that's how much food you consume. If you want to put on weight, once you realize how much energy your body requires to function daily, including your training, if you want to put on weight, then you add 500 to that amount. So you can either be in a surplus or you can be in a deficit. Does that make sense to everyone? We're all on the same page.
Yes, yes, it does.
So it
Sorry,
really is. Yeah.
I just didn't hear the fact that you said the 500 what was it, grams that you said should be added to which, were you
Calories.
referring to the BMR or what?
No. So the E out. So your total energy
Okay.
burned for the day. If you want to lose weight, the amount of food that you would consume is that number minus 500 in terms of calories. If you wanted to put on weight, you would take 500 and add that. So let's say the amount of energy you require per day is, let's say, in terms of energy, let's say it's 2,000 calories, right? If you wanted to lose weight, hypothetically, you would then take 2,000 calories minus 500 gives you 1,500 calories. You then take 1,500 calories. That's how much food you will consume every day. So then you take that and you can be like, okay, cool. Well, my protein is at 200 grams of protein per day. And I know that there's 4 calories per gram. So 200 times 4 gives me 800. And now I have 700 calories left. So very quickly you realize, hey, there's actually not that much food when you're eating those low amounts. And then that's when you start to play with it. Or if you wanted to put on weight, then you would know that it would be 2,000 plus 500, so you'd have 2,500 calories to play with, and then you divide it based on your food. Does that make sense? How you go the process of elimination?
Okay. Yes.
Cool. Now, if we look here at the energy balance, each gram of protein we consume contributes 17 kilojoules or 4 calories of energy. Guys, I would advise that you just stick to calories. Understand the influence of kilojoules on how you calculate calories, but don't keep going between kilojoules, calories. Choose one and stick to one, else you're going to get confused. Each gram of carbohydrate we consume contributes, again, 17 kilojoules or 4 calories, and each gram of fat we consume contributes 37 kilojoules or 9 calories of energy. Each gram of alcohol we consume contributes 29 kilojoules or 7 calories of energy. So do you see what I mean? Like even drinking alcohol, where people may be like, yeah, but I'm not eating that much. But if you're drinking a lot of alcohol, you are getting nearly double the amount of calories that you would get from the same amount of carbohydrates or protein. And that's whereby so many people would put so much energy in throughout the week to lose weight, etc. And they get to the weekend and all of a sudden they're having a case of beer, 2 bottles of wine, and granted they maybe haven't eaten badly, but they're now in a position whereby they've consumed so much alcohol that they've actually, now sitting in a surplus rather than being in a deficit. Oh, sure. No, all in moderation. All in moderation. But that's where it's good for people to understand. Because if you don't know that, how can you calculate for that? How can you, and the same with your clients, like they may be like, I ate on plan the whole weekend, but their weight's gone up. Okay, how much did you have to drink? Now all of a sudden you can then be like, okay, cool. If you know you're going to go out, maybe we're going to reduce this meal, or we're going to take this meal out for today to account for the gain that you're going to get, or whatever the case may be. And that's where people get despondent, because they go and they'll put on, but then they need to work even harder to burn it off. And especially once they've worked so hard, they forget that those 3 hours or 4 hours of joining or having a braai or whatnot, and consuming the alcohol. Not that alcohol is bad, but people just don't take in the caloric expenditure that is involved in consuming that. And when you have that, that's when you need to work harder to burn, etc., etc. Now, if we look at your basal metabolic rate, so this is how we calculate that E out. It's one of the factors. The BMR represents the energy the body uses to carry out the basic metabolic needs, of the body. Energy must be provided for maintaining a heartbeat, breathing, regulating body temperature, and carrying out other activities that we take for granted. Most of our daily energy expenditure is about 60 to 70% is represented by our BMR. Energy balance. A person's actual BMR changes over time. This depends on several factors, including several that distinguish age groups of people. So if you look at age, younger people have higher than average BMRs. As children grow, their body composition percent of body fat and muscle mass changes. As they continue to age, BMR decreases as the percent of muscle mass decreases. So this is only in some cases, which is why it's so important that people train, because if they train and they putting on that healthy muscle mass, they are able to keep their BMR relatively high, so therefore they are still burning adequate amounts of energy, which decreases their, not the amount, but it decreases the amount of weight that they're going to put on. So they can still consume relatively high amounts of food, but not necessarily put on fat. And then growth. Children and pregnant women have higher than average BMRs. Height, tall, thin people have higher than average BMRs, and body composition, people with higher than average or increased muscle mass have higher than average BMRs. So that's why muscle is such a great tool, because it's healthy, it encourages the burning of energy, etc., etc., etc. Other factors that cause variation within individuals, now this is you looking more on the other side, is, for example, if people get sick, if they have a fever, stress can increase your BMR. If you look at stress, physical stress such as recovering from an illness increases your BMR. Mental or emotional stress may lead to lethargy or depression and decrease your BMR. So remember what I said earlier about mental health. Emmanuel asked, but what if they're eating in a calorie deficit and they're not losing weight? Well, there we go. You can see how the BMR decreases, so therefore they're not burning as much. Therefore, in theory, you are still in a deficit, but because their body isn't burning as much, it's not as big of a deficit that you may think that it is. Inside or outside temperature, both heat and cold raise your BMR, and fasting can help lower your BMR. So some people use fasting so that they can, it lowers the BMR so that they can eat less, but not necessarily feel as hungry, because their basal metabolic rate has dropped, so they're not burning as much as quickly. Does that make sense to you guys? So therefore they are able to, eat slightly less, but not have that hunger sensation. Then you have physical activity, which amounts to about 20 to 30% of the body's total energy output. I'll get to your question now. Energy expended during physical activity varies with the level of duration of the activity. It is also affected by the age, gender, height, and weight of the individual performing the activity. And then the last one was that thermic effect of food, which refers to the energy required to digest food. This term indicates energy that must be expended in order to make nutrients available in the body. Yes, Melo, you had a question.
Yes, no, I just wanted to ask, is the reason why you use the basic metabolic rate as opposed to the resting metabolic rate because of the applicability of the BMR to uh, everyday situations? Because obviously the resting metabolic rate is more strict as far as like when you calculate, the rate as
Well, there would just be a hell of a lot of variance, whereby basal metabolic rate is slightly more accurate, because resting metabolic rate, sorry, not weight. How are you going to make sure that that is accurate on a day-to-day thing? You'd have to measure every single day and then get the average of the week, and then make sure that you have the same week next week to ensure that that stays the same, where basal is more of an approximation.
okay.
If that makes sense.
Okay. Yeah, makes sense. Thank you.
Right? Because when you're trying to do this, imagine how painstaking it would be if every single day, depending on your client's day, you'll have to adjust their nutrition accordingly because every single day their resting metabolic rate, their RMR could also be slightly different. If that makes sense. Cool
Yes,
beans.
yes, it does.
Now let's do food groups. If we look at food groups, here we're going to be looking at the various different ones. This is just all straightforward, guys. I'm sure you guys have seen the food pyramid before, and it's just merely, the old one was how we've had all the carbs at the bottom, then we had fruits and veg, and then you had, your proteins and your dairy, and then at the top it was always like sweets and, and how low something was, you ate more of it, and then the higher you got up, the more the least you have. When in actual fact, the pyramid should be more like this. Everything has a unique spot. It all just depends where it is. You know, um, they all have a decent amount, but the food groups are, you have your grains, your vegetables, your fruits, meats, and your dairy products, and then you also have more of the oils. Of course, we can already know that oils is going to be the least amount, but there is effectively a balance amongst the rest. You're probably not going to eat as much meat as you are going to consume grains or vegetables or fruit. Why? Well, there's various financial reasons, but also, just the overall satiety and the flavor and the enjoyment of the process will be slightly different. And that's when you start to look at this, that each one has a valid point, and why you have it, and that functioning, each individual will have a different food group pyramid because each individual's pyramid will be slightly different depending on A, what they want to do, and B, the performance that comes with what they want to do. So it's not just about, well, we do the old school type food pyramid and we draw it and there you go. But it is important to understand the old one. You may get asked to, you'll get given this pyramid and you may get asked to please label the 6 different categories. So then you'll need to kind of know from the bottom up, you have your grains and your fruits and veg, then your milk and your meats, and then you have your fats and oils and that at the top. But it really is based on an individual to individual basis. Does everyone understand this food group slide? All good.
Just
Yeah.
a little question from my part. Just going back to the pyramid now, is it
Yeah.
this is just off of the the topic per se. Is it a possible question in an exam situation, so to say?
I have seen it before. I've seen it before, but I wouldn't
Okay.
pay too much attention to it. I mean, like I think you guys are more than smart enough to apply logic. And in that sense, I mean, you guys are more than smart enough to able to look at something and be like, hey, you know what, like, grains at the bottom, fruits and veg, meat and dairy, and then the oils and the not so healthy things at the top. Try and simplify it. It's not about trying to remember everything, it's about applying it. If you can understand the system that you're working in, application will always get you further than trying to parrot learn something. Always.
Thanks.
9 times
Thanks
out
a
of
lot.
10. 9 times out of 10. All right. Now, if you look at food labeling, there's various different dietary information on food labeling. What's also important to know on food labeling is that certain things are legally required to be on labels, right? So, and we'll get to those now, but there are certain things that have to be on labels so that people need to know what's on them. Right. For example, ingredients. It would be great. Heaven forbid you bought something and you didn't know what the ingredients were. Next minute there's something that you're allergic to or you don't like. So it is to provide information to people, but it's not just about that. It's also about bringing awareness of different things for specific conditions or whatever the case may be, if you guys understand what I mean by that. Now, categories of dietary reference intakes, or DRIs. The term DRIs is a collective one and refers to a set of at least 4 nutrient-based reference values, also known as NRVs. Each type of DRI refers to the average daily nutrient intake, and it is to be understood that some deviation around this average value over a number of days would be expected. It is therefore the average mean intake over time that is nutritionally important reference value. Now, there are 4 different reference values. You have the EAR, the RDA, the AI, and the UL. Not AI as in like the intelligence, but AI in terms of the food label. Now, what these are is different pieces of information. So you have the recommended daily allowance. This one will be the most common one you see on food labeling, because you'll see it will say ingredient, it will say total amount of calories, total amount of per serving, etc. And then you'll have a little column that says RDA, and then all of a sudden, you know, okay, cool, that is the recommended daily allowance. Like that is how much people have tested, and that's how much you should be consuming per day of this if you want it, you know what I mean? So it all will be individualized, but it's just to put people in the ballpark so that it's there, so that for those people who don't know can know, but for you guys who will know, then you can mitigate it towards what you want to get out of it, the product. So for example, the EAR, this is the estimated average requirement. It is defined as the intake that meets the estimated needs of a nutrient of 50% of individuals in a specified gender group at the given life stage. The EAR is the dietary intake value, and it includes an adjustment for an assumed bioavailability of the respective nutrient. The EAR is used as the basis of setting the RDA. If sufficient scientific evidence is not available to establish an EAR, then there is no RDA to set. So because you use an EAR to develop the RDA, if you aren't able to get the estimated average requirement, then you can't get the RDA. So you'll see how one leads into the other. It's mainly just from a science point of view. It's, for example, like if you are wanting to do maths and you're trying to count how many apples you have, but if you don't have apples to begin with, how can you calculate how many apples to put in the basket? Does that make sense? So you can't, if there's no apples on the tree, you can't count how many apples there are, so you know how many to put in each basket. So it's pointless to try and tell someone that they need 10 apples, because you don't really know that they need 10 apples now, do you? Because you first need to be able to count how many there are on the tree, so know how many you can pick, to then know how many you can divide equally into each basket. If that makes sense. Therefore, the RDA, the recommended daily allowance, is defined as the intake that meets the nutrient needs for almost all individuals, 97 to 98% in that gender group at a given life stage. It is important to recognize that RDA provides a good guideline for nutrient requirements for individuals in a particular group, but it is not specific to an individual who can have higher or lower nutrients needs depending on a state of health or activity level or genetics. So it's to show that all that it's trying to do with these things, right, is to put people in the ballpark, right? To just give people information that probably 9 out of 10 individuals are not going to pay attention to, but for that 1 out of 10 individual who does want to know, that they've covered their base, right? And that's all that really is even if you look at the next one, adequate intake is used in a case where the scientific evidence is inadequate to set an EAR. So if you can't use EAR, therefore you can't use RDA, therefore you can use AI, which is ironic because of automatic intelligence. So, but the point being is that the AI is based on experimentally derived intake levels or approximations of observed mean nutrients intakes. And look, guys, I've gone quite in depth with these definitions. Don't feel overwhelmed by it. You guys will have much simplistic definitions in your workbooks or whatever the case may be. Use those, please, because these you can use just to touch base with, but please use those. Then you also have the UL, which is the tolerable upper intake level, which is defined as the maximum nutrient intake by an individual, which is unlikely to pose risks of adverse health effects in almost all 97 to 98% of individuals in a specified group. And then you have NRV, which is probably the most common one, which you're going to find on most food packaging, which is the nutrient reference value for the general population of 4 years or older for the purpose of food labeling. So you'll get all of these at some point or another on a label, but majority of the time you'll find NRV. Now, when I say you'll find NRV, you'll then be able to apply that. And going forward in terms of tests, they may say, what are the 4 different reference values? So you'll just say EAR, RDA, AI, UL, NRV, potentially. I know there's 5 there, but the AI and the UL almost form like one. But you'll be able to tell them, what they are. So you need to know that EAR is the estimated average requirement. You need to know that RDA is the recommended daily allowance. The AI is the adequate intake. The UL is tolerable upper intake level. And then NRV is the nutrient reference value. So you may need to be able to know that. You may be able to list them. I'm not sure what they're going to do for you guys this year. It could be match the column or whatever the case may be. But please don't sleep on these definitions or on these acronyms or abbreviations rather, because I don't want you guys to forget and then it's marks for jam. Like these are really easy to learn and you can really get some free marks here. But that, for the sake of labeling, is what we put on. Now, food labels, proper labels must make it easy to determine the amounts of nutrients you're getting, to compare one product to another, increase the awareness about the consumption of excessive sodium saturated fats, trans fats, cholesterol, and added sugar. So it's also to notify people of what's in the product. And then furthermore, when we look at South African law, it's also important to ensure that these are on all the different packaging. So you need to look at the best before, right? That is on all of our packaging. The product name or description is on all of our packaging. The ingredients listing, right? Allergy advice, right? This contains peanuts. If consumed, please seek medical attention as soon as possible, for argument's sake. Nutrition information, storage use and instructions, and then you also have the size. So is it 400 grams is the packaging? Is it 200 grams is the packaging? So that people know how much packaging is in there. So then we know what the serving size is going to be. It's all about just giving people information so that they can make as independent and as accurate of a decision as they can possibly make. Does anyone have any questions on the food labeling or the food groups?
I think this section requires careful studying and understanding it as well.
No, of course. Look, but what I will implore you guys to do is please read through your textbooks, because here I've gone quite a bit in depth, right? Chat to your tutors, go through the work, and just make sure that you get a basic understanding. I wouldn't, honestly, if you're looking at nutrition, I wouldn't let this food labeling section be something that stresses you out, right? Really, if you know the different abbreviations, if you know roughly what should be on the label, and you can just think about it, just you use logic. What would you like to have on something? What information would you like to know? Hey, I'd like to know when this expires. I don't want to eat off food. I'd like to know what the name of the product is. I'd like to know what ingredients you have in there. There's already 3. I'd like to know what should I do if there's an allergy in here, or there's something that gives me an allergic reaction. What do I do? Do I go to a doctor? Do I take an Allergex? Like, what should I do? So there's also that, and then storage. Must I put this in a pantry? Do I put it in the freezer? Where do I store it to make sure that it increases its shelf life, but also where it's not going to go off and then attract chojos and mold and all of those good things. And that's, if you ask yourself that, then you should be right away. So I really would not make it something that gives you more stress than need be. You know, um, just see what would the level of detail that your tutor would like you to have, and then just make sure that within the confinements of that. Sound good? And then the last thing we're just quickly going to go over here is dietary supplements. All right. When you look at dietary supplements, all that I want you guys to know is that you get your multi-vitamins and mineral supplements, you get various different omega-3s, you get vitamin Ds and your calcium supplements, you get your antioxidants, your special needs. Now there, you're going to be looking at protein, creatine, pre-workout, etc. What is special to you? And then you're going to have your botanicals at the end. Now, what this is doing, because you see the pyramid, now this is showing you, like, if you're going to start getting supplements, you want to first make sure that you have your multivitamins and your minerals sorted, right? Excuse me. Then you're going to look at more of your fatty acids, because we will look at the importance of what fats give to the body. Remember that insulation, that neuroprotective approach. Then your more vitamin Ds, right? They're not going to be as important as your vitamins or minerals. Why? Because vitamin D you can also get from the sun, right? And then calcium you're also getting from food, right? So it's slightly higher up on the level because it's not necessarily needed as often. You then also get your antioxidants, and then your more special needs, like more for your performance based, and then your botanicals at the end. So it's all about logic. Like, you first want to make sure that your body functions properly before you get all the way there. Now, that's not to say that you need supplements. Supplements are exactly that. They supplement what the effective real one should have been, right? They are supplements. I would advise that you always try to get your vitamins and minerals in through as natural of a source as possible, and then use the supplements to bridge the gap. So even if you know you're going to go and eat a fruit salad, and you're going to go and eat vegetables, and you're going to go and eat your protein and your carbs and your fats and all of that, nothing's stopping you from just having a daily multivitamin. I'm not saying multivitamins are bad. I'm just saying that don't use multivitamins to be the cure for something that needs specific dosage. Does that make sense? Because multivitamins are spectrum based, right? Because there's more than one, but they may not have the adequate amount of dosage for a specific deficiency. Now, that's more what I was trying to lead towards. But you start with what would you want, and then you work your way up. But a lot of the time, you can get it from basic food. But if you are in a position whereby you can afford to get the supplements, and the supplements would help save on time, save on ease, enable you to stick to getting them in more because you're able to get them in more of a quick form, or whatever the case may be, then by all means, use that, apply it. Use the supplements, you use protein, you use creatine, use pre-workout if that's really something that you want to do. But before you start to look at supplements, make sure that you are getting as close to your daily requirements from natural sources, from your food. It will aid your digestion, it will aid your performance. But overall, it will probably end up being a little bit cheaper. But in some cases, sometimes getting that amount of protein in, not everyone wants to eat chicken every single day, or large amounts of chicken. So therefore, that's where, for example, protein powder comes in, etc., etc., etc. And it's the same with the vitamins and minerals. Sometimes you don't really want to eat um, a salad because maybe it's cold, or you just don't feel like salad. So then you can slowly over time, you can build up that one through using some supplements as well. But they are not going to solve a problem unless you are ensuring that you're getting majority of your basic nutrients from food. And that is it, ladies and gentlemen. We've gone through a recap. We've gone through macronutrients, we've gone through micronutrients, we've gone through the different food groups, we've gone through labeling, and then now at the end, we've now gone through the various different dietary supplements. Any questions?
But from my side, thank you so much, Cameron. This has been quite insightful. I'm glad I was able to join the session today. I
No
look forward
worries.
to. I'm gonna drop you an email as well, so you can send me the
No
slides,
worries.
and I can always
Yeah.
just refresh on them as well. But thank you so much for being explanatory as well. It's been quite an
No,
interesting
only a
session.
pleasure. Only a pleasure, guys. And look, the main thing is what we keep talking about the client, right? Keep talking about the client. And the client is important. But what I want you guys to encourage yourselves to do is become a better asset to yourself. You know, we have this, we live in a time where we have this continuous instant gratification, where we have all these various different things. And ironically, we aren't improving ourselves, you know, in that sense, you know, because we're so focused on other people, we're so focused on other things. All that I would say is make sure that you use this to become a better asset to yourself. If you become a better asset to yourself, you can become a better coach, you can become an individual, you can become a better man, a better woman, a better person to society. And overall, if we can get more people improving their life, we can hopefully get more people inspiring others to live a better life. We can get more people contributing to society. We can get more people who want to see change in the world, who want to break the socio-economic barriers, who want to improve the lives of others. But you have to start by improving your life. So please take that forth. Chisetso, you want to ask a question? How can I help?
Hello again. It's there. I've stated something on the chat group. Sorry.
Okay, no worries. Need to focus more on hormonal balance and regulation. Yes, look, guys, there's all of these different things. I'm just going to stop the recording and then we can get to some of these questions. Let me just stop the recording. Yes, all right.